Hey guys, welcome to video tutorial. This will be beneficial for those of you that are wanting to learn more about momentum. So what we talked about today was momentum, and we also talked about impulse. Okay. If my computer will catch up to what I am doing. Okay, so momentum we said was denoted with a lowercase p, and we said it was the mass times velocity. Impulse is denoted with a capital J, and we said that was the change in momentum. Now, we talked about how momentum is a vector quantity, so it has both a magnitude and a direction. And we said that the units on this were kilogram meters per second, which we simplified down to Newton seconds. So, momentum is in Newton seconds, and impulse is also in Newton seconds. Now, Jude really hates momentum and impulse. Now, since we are talking about momentum and impulse, it helps to talk about the momentum-impulse theorem. This is where we develop the equation FAT-AP. So this is where we found that the force times the time, Newton seconds, force times the time equals your change in momentum. Now, change in momentum we broke down as mv final minus mv initial. Because if we thought about it, delta P, all it means is P final minus P initial. Just like delta Y means Y final minus Y initial. So, we found that delta P is mv final minus mv initial. So another useful equation was this right here. Force times your change in time equals mv final minus mv initial, because delta P equals mv final minus mv initial. So that's pretty much it. These two formulas and then this formula are crucial when dealing with momentum and impulse. Now, that's not to say you won't need to use your other kinematic equations, but these are the main equations that deal with momentum and impulse, which we are going to lead up into talking about collisions. Now, let's look at our physics problem, specifically your worksheet that I gave you today, problem 4. So, 4A, first we've got a golf ball and it weighs 0.45 ounces, so let me scroll down here. And so we've got a golf ball and its weight is 0.45 newtons. And we say that it falls a height of 1.3 meters. Now, they want to know in part A the time it takes for the ball to hit the floor. So just before the ball hits the floor, they want to know how much time is required. Okay, so time equals what? Now, it says it's dropped, so if something is dropped, we know that our initial speed is 0. Now, we need to assume that this ball, or this golf ball, is on Earth, so our acceleration is going to be negative 9.8 meters per second squared. Now, our height is 1.3, but since the ball moves down, that means that our delta y is negative 1.3 meters. So we know the initial speed, we know the acceleration, and we know the height. We are looking for the time. If you think back to projectile motion, what always gave us time was our delta y equation. So in part A, you need to utilize delta y equals v naught y t plus 1/2 a t squared. We already said that our delta y was negative 1.3. Our v naught y is going to be 0 because we drop it from rest. So that leaves us with negative 4.9 t squared. So we divide both sides by negative 4.9. Remembering that our negatives are going to cancel because we should never end up with a negative time. So that gives us let's just say 0.265 equals t squared. So square root both sides, and you end up with 0.515 seconds equals t. So that is our answer for part A, how much time it takes for the ball to hit the ground. So shimmying over and working part B. Part B asks us, what will the instantaneous momentum of the golf ball be immediately before it strikes the ground? Okay, so instantaneous momentum, all that's asking is, what is the momentum right before the ball strikes the ground? Okay, so to break that sentence apart, all they're asking for is, what is the momentum? Now, two pieces of information we need. We need to know the mass of the golf ball, and we need to know the velocity of the ball right before it hits the ground. Well, to calculate mass, we're going to use the ball's weight. Now, we know that weight is just another way of saying the force due to gravity. So the force due to gravity is mass times gravity. Well, if my weight is 0.45, to calculate mass, all I need to do is divide by 9.8. Now, I've made both of these positive because we know that weight is directed down and it is negative. And we know that gravity is directed down, so it is also negative. Those two negatives cancel each other out, leaving you with a mass of 0.04, let's just say 0.046 kilograms. Okay, so that's my mass. One piece of information done. Now, to calculate the velocity, I know the initial speed, I know the acceleration, and I calculated the time. The piece of information that I don't know is v final. Well, I can use this dandy old equation right here. V at. I know that my v initial is 0, so I'm left with my acceleration times my time, which is 0.515 seconds. So 0.515 times negative 9.8 gives me a final velocity of 5.0, let's just say 5.05 meters per second, and it is going to be negative because it's directed down. So now that I know my mass, which was right here, I also know my velocity. I can now calculate momentum. So momentum equals my mass, which is 0.046, times my velocity, which is negative 5.05. So that leaves me with a final momentum of negative, let's just go negative 0.232 Newton seconds. Let's actually put in that negative sign. So that is the momentum the ball has right before it hits the ground. Now, the next part tells us to find what will the change in momentum be from the instant before the ball collides with the floor until the instant after it rebounds with the floor. Now, a crucial piece of information here, it says no energy is lost due to heat. The ball will bounce back up to its original height. So, what that tells us, let's go part C. What that tells us is now I need to know the speed of the ball after it collides with the ground. So it says it bounces back up to its original height, so that means it's going to travel up 1.3 meters. Now, the speed at the very top is going to be 0. So I need to calculate what my initial speed is. Now, I don't know the time, but I do know the height, and I also know the acceleration. So you have to utilize the one equation that does not involve time. That is v final squared equals v initial squared plus 2a, in this case, delta y. Now, delta y is going to be positive, and I know that my v final is going to be 0. So 0 equals, v initial is what I'm looking for. 2a is going to be minus 19.6, and then my height is positive 1.3. So 19.6 times 1.3 gives me 25.48. So 0 equals v initial squared minus 25.48. Let's actually make that a good looking 2. Add that to the other side, and then take the square root. So the square root of 25.48 gives me, holy cow, look at that. My rebound speed is going to be 5.05 meters per second. So it is positive, which means my momentum is going to be positive 232 Newton seconds. Now, they asked us to calculate the change in momentum. Well, that is P final minus P initial. So my P initial was negative 0.232, and my P final was positive 0.232, minus a negative 0.232. So that, in a sense, doubles our momentum. So my change in momentum is positive 0.464 Newton seconds. A negative minus a negative makes it positive. So that would be your answer for part C. Now, the last part, part D, asks us about the force. It says, suppose that the golf ball was in contact with the floor for 4.0 times 10 to the minus 4 seconds. What was the average force on the ball while it was in contact with the floor? So they tell us that the time is 4.0 times 10 to the minus 4th. So 4.0 times 10 to the minus 4th seconds. And they want to know the force. This is where you utilize the equation FATAP. We calculated delta P, it was 0.464. And I know my time is 4.0 times 10 to the minus 4th. That equals 0.464. So if I go 0.464 divided by 4 times 10 to the minus 4th, I get a big old force. I get a force of 1,160 newtons. So that is your worksheet in a nutshell, and that is some very excellent practice on momentum and impulse.